hit the record button. Oh,
You're okay with the name? Is that okay, or you want me to change it?
that's perfect.
Okay.
That's perfect. Okay, so we go back. So we are looking at question 4, right?
Question 6.
Question 6. A cylinder can, with an open top. Oh, I was reading can like able to, but it's a can. Okay, so a cylindrical can with an open top has a surface area of 3 pi meters squared. Find the radius and the height of the can that will maximize the volume and find the maximum volume. So the first step for this problem, we are dealing with volume, right?
Right.
So they have given us the surface area. So the surface area of this cylinder is 3 pi square meters. So they want us to find the radius and height of the can that will maximize the volume. So we know that the surface area of this cylinder is going to be pi r squared, right?
Okay.
Pi r squared plus 2 pi r multiplied by h, right?
Mm-hmm.
And this is equal to 3 pi. It's equal to 3 pi, according to the question. Do you realize we can divide everything by pi?
Yeah. Okay.
And so we know that 3 is equal to r squared plus 2 RH. Okay, and also we could write this as 3 equals r, and then this is r plus 2h. But we are not interested in the surface area. We are interested in the volume. So the volume for this one, it's the volume of a cylinder. It's given by pi r squared h, right?
Yeah.
And then we have 2 variables. So I intend to use this equation to express one variable in terms of the other.
Okay.
So I have 3 equals r, and then r plus 2h. You can see that I could write the equation star. I could say 3 divided by r equals r plus 2h, right?
Mm-hmm.
And what does this mean? This means that 2h is going to be equal to 3 divided by r minus r, right?
Right.
And so h is going to be equal to 3 divided by 2r minus r divided by 2. Okay.
Mm-hmm.
So the volume V equals pi r squared h. We are going to substitute the h in that formula with whatever we just created. So this formula is going to be V equals pi r squared, and then h is going to be 3 over 2r minus r over 2. Okay.
Okay.
Now we can use this equation to maximize. What do you know about maximization first?
If we find the, I think, derivative or the relationship between the two variables, then we can set the first derivative equal to 0 to find the maximum or minimum.
Yeah, that's right. So all we need to do, we need to compute dv dr, right?
Okay. How do you decide which one is on the top or the bottom?
What do you mean?
Or how do you decide which variable to solve for?
Between r and h, or what?
Yeah, like what prevents it from being dr over dv?
Oh, okay. So what prevents it from being dr over dv? It's because, you know, first of all, this statement means that we are integrating the whole thing, right?
Right.
Again, you could think of v as a function of r. V is a function of r. So r is the
Okay.
variable, and then v is the output. And whenever we are differentiating, we always have the output on top.
Oh, sure.
Yeah.
Okay.
Yeah. So it's a function of r. We are differentiating it with respect to the variable r.
Okay. That
Yeah.
makes sense.
Yeah. Okay. So dv/dr. So can you compute dv/dr for this one? Of course, you're going to use the product rule, right?
Mm-hmm.
Okay. Can you give it a shot?
This will be fun.
Mhm.
Okay. 2 pi r, I think. Are we gonna? Yeah, we can do it in that order.
2 pi r.
2 pi r.
Okay.
Multiplied by just the second half, so 3 over 2r minus r over 2.
Minus r over 2.
And then that whole thing plus pi r squared.
Plus pi r squared. So
Oh, if we have to differentiate the r, do we have to put in dr over something else? Or
no, no.
Okay, that's only when you have 2.
Yeah.
Okay. Yeah, so pi r squared. And then, would that be -6 minus no, plus 2?
-6 plus 2. How did you get that?
It's 3 multiplied by 2r to the -1st.
Okay.
And then you can,
So 3.
-6r to the -2nd.
So it's
Maybe.
going to be, so if you drop this, if you are differentiating this, this is going to be -3 r -2, right?
But there's an extra 2 in there, right?
Where?
It's 3 over 2r.
Oh, yeah. So there is a 2 down below. So it's going to be -3 over 2 r squared.
Okay.
Like this.
Oh, sure.
Yeah.
Okay.
And then the second one?
Second one, we could write that as r. Yeah, just 1 over 2r. So
it's going to be,
it would just be 1 over 2.
1 over 2. And so this is the derivative, right?
Right.
And this is the thing we are going to equate to 0 and find the value of r.
Okay.
Yeah. Okay. So let's equate this to 0 and see what happens. So first of all, if we equate this to 0, you agree with me that one of the solutions is as 0.
What?
You see, if we equate this to 0, we could write it as r, and then we have 2 pi, and then you have 3 over 2r minus r over 2, and then this is going to be plus pi r, and then this is negative 3 over 2r squared minus 1 over 2. I just factored out the r,
Sure.
and then we are equating this to 0. Again, we can divide everything by pi. So let me write it on a clean piece. But if I do that, I'm going to lose everything that we wrote. So let me create some
Can you-
space. So if we divide everything by pi, we are going to get r, and then the 2 pi just becomes a 2, which we could write as 3 over r. So this is 2, this is 3 over 2r minus r over 2, and then we already kicked out the pi. So this is going to be plus r negative 3 over 2r squared minus a half. I guess it's simple enough now. And this whole equation is equal to 0, right?
Mhm.
So let's distribute. So this is going to be r. If we distribute the 2 over, this will just become 3 over r, right?
Yeah.
Minus r. And then if we distribute the r over to the other one, it becomes negative 3 over 2r. Negative 3 over 2r. And this is going to be minus r over 2, right?
Right.
Can you simplify whatever we have in brackets? You have 3 over r minus 3 over 2r. So you're going to have r. So 3 over r is the same as 6 over 2r. So if you subtract 3 over r minus 3 over 2r, you get 3 over 2r, right?
Yeah.
And then if you do minus r over 2, it gets you to minus 3r over 2. Now, this is the derivative. After equating it to 0, we simplify it to that. Okay.
Okay.
So what we need to do now, you could assume r is 0, or you could assume that 3 over 2r minus 3r over 2 equals 0.
Right.
And then let's solve this. Let's multiply everything by 2r. What do we get? We get 3 minus 3r squared equals 0, right? And if we solve this for r, it only means that r equals 1. Okay.
Okay.
So for us to get the maximum radius, the maximum volume, we need r to be equal to 1. Okay. And
Right.
remember, we started by saying that h was equal to 3 over 2r minus r over 2, right?
Mhm.
If you substitute the value of r with 1, I think you get 3 over 2 minus 1 over 2, which is 2 over 2, gives you a 1 again. So the answer for question 6 is the radius and height that are going to maximize the volume, they are going to be 1 meter for the radius and 1 meter for the height. It was quite long. Did you follow?
I think I did.
You did, right?
That was, yeah, that was very helpful.
Yeah.
Thank you.
I think I'm going to do the next problem on a clear page.
Sure.
Yeah, they are quite long. The margins are not enough.
Yeah.
Yeah. So which one should
The
we
next
attempt?
one, can we look at number 10?
Number 10. Okay. So a piece of wire 80 centimeters in length is cut into 3 parts, 2 equal circles and a square. Find the radius of the circles if the sum of the 3 areas is to be maximized. Okay. So, yeah, thanks so much for introducing me to Kami.
Sure, it's a great tool.
Because I'll just go to Kami and then I will ask them to give me a blank page and they can give me as many pages as I want. So I can even ask for 20. There you go. So let's work on this.
Very nice.
So we have a piece of wire. It's 80 centimeters in length and it is cut into 3 parts, right?
Mhm.
So I want to assume my wire is straight and it's 80 centimeters in length. But now we are cutting it into 2 parts. The first 2 parts are equal. I don't think the other one is going to be equal, but this one forms a circle. This one also forms a circle. And the other one, what does it form? Let's see. So the other one forms a square, right?
Mhm.
But we want to have the sum of the 3 areas. We want them to be minimized. So this will be a square. So let us look at the function that we want to minimize. The area of the circle is given by, the circles are equal. Let me check again. 2 equal circles and a square. So if that's the case, then the area for this one is going to be pi r squared, right?
Right.
And then for this one, it's going to be pi r squared as well. Okay, so we want to write the area of the square. What should we write? So this is
Maybe
the area
X
of circle
times X.
1. Okay, x times x. But your choice of a variable is going to give us trouble. You know why?
Why?
We want to come up with an equation of one variable. we already have a variable r. So your choice of the variable for the square should also involve the r. And you
Okay.
cannot say r times r.
Oh. Okay. 80 minus r to the power of 4 times squared, yeah.
Like that?
And then that whole thing is squared. Yeah.
How did you get that?
Because r squared is used 2 times already, so we know that length is gone from the wire. And then in order to get the area, so that would be one of the sides maybe. Or no. That would just be the whole thing. So if we divide that by 4 and then square that.
Okay, come to think of it, this piece, the first piece of the wire, it's the circumference of this circle. It's the length all around, right?
Oh, yeah.
So the
sure.
first piece is going to be 2 pi r, right?
Mm-hmm.
And the second piece is also going to be 2 pi r. It means that the last piece, it's going to be 80 minus 4 pi r. And that is the piece that we used to create the square.
Okay.
So to get one side of the square, you have to divide that piece by 4.
Right.
And so this is going to be 20 minus pi r. And so the area for the square, it's going to be 20 minus pi r squared. Okay.
Okay.
Yeah. So we want to sum all the areas. So the function that we create, it's going to be a function of r. And it's going to take the area of the first circle, pi r squared, another pi r squared. So that's 2 pi r squared. And then we add the area of the square, which is 20 minus pi r squared. And this is what we want to minimize. So to minimize it, we are going to do the same thing we did for question 6. We are going to find d dx of this function, d dx of 2 pi r squared plus 20 minus pi r squared. And then once we find that derivative, we equate it to 0. And then we solve for r. Did you get that?
I think so, yeah.
Yeah. So can you find that derivative? Can you find that derivative?
Yeah, sure. So I think it'll start off with just a regular power rule. D over dx is 4 pi r.
Okay.
Plus then the chain rule, 2 multiplied by 20 minus pi r multiplied by minus pi.
And this is what we are equating to 0.
Right.
So we can divide by pi. And if we do, we will get 4r minus 2 times 20, 40, plus 2 pi r equals 0, right?
Okay.
And then we could make it simpler, or maybe we could just combine the like terms. So we could write this as r, and that is 4 plus 2 pi equals 40. And so the radius is going to be 40 over 4 plus 2 pi, which can be simplified to 20 over 2 plus pi. Right?
Right.
So if we go back to the question, it was asking us to find the radius of the circles if the sum of the 3 areas is to be minimized. And this is going to be the radius of the circle. Yeah. Can we verify that it's a minimum point?
Maybe. I think so.
Please do. Please verify that this is a minimum point.
Okay. Let's see. If this is a minimum point, then if we plug in a number greater than this,
Mhm.
it should return a positive number
You should do that using the second derivative.
using the secondary. Okay.
Yeah, you know that if the second derivative of the function with respect to r, if it's less than 0, it's a maximum. If it's greater than 0, it's a minimum.
Right.
So going back, we can see that the second derivative, what is it going to be?
4r plus 2 pi.
4r plus 2 pi. How did you get that?
From this second line here. Let me.
You should differentiate this equation. This is the first derivative, so you should differentiate that to get the second derivative.
I can't use the simplified one.
Oh no, refrain from that. Use the fresh one.
Sure. Okay. So we would start off with 4 pi minus 2 pi. Yeah.
4 pi.
So that's just 2 pi.
4 pi minus 2 pi. But I guess we also have a minus pi, right? This is 4 pi.
Okay. Yeah.
We can write this as negative 2 pi. This will be differentiated to 0. This will be differentiated to negative pi. And actually the minus 2 pi and the negative pi, they give us a positive 2 pi squared. So this is going to be 4 pi plus 2 pi squared, right? And you can see that this value is greater than 0, right? And because it's greater than 0, it satisfies the second condition. And so the point that we found out, the value of r is going to give us the minimum sum of the areas. We just verified that.
Okay,
Yeah.
that makes sense.
All right. We go to the next one. Let me go back
Sure.
to the
Oh,
book.
okay. Can I ask questions about this one?
Yes. Which one? About which one?
The one that we just did for 10?
Okay. Yes, you can. Let me go back to that.
In the derivative that we just did, the second derivative,
Mhm.
can you explain why you got where you got the minus 2 pi and the minus pi from?
Okay. So you understand this part. It gives you 4 pi, right?
Yeah.
So I think I can rewrite this equation. I could rewrite it as 4 pi r. And then I have 2 and minus pi. It's going to be minus 2 pi, right? And then I
Okay.
have the 20 minus pi r. So I could rewrite the equation like that, right?
Okay.
And then now I differentiate. This becomes 4 pi. I think you don't have a problem there. But now when we come to this one, we have the constant 2 pi. We keep it, right? And then we need to find the derivative of what we have in the brackets. What do we have? 20
Wait, why,
minus
why
pi
are we
r.
keeping it as a constant?
Why we are keeping it?
Yeah, the minus 2 pi.
So we are keeping it because the product rule allows us to keep it. You know how? You know how?
Oh, sure.
Because if you think of the 2 pi multiplied by 20 minus pi r, the product rule says that you can differentiate the constant, becomes a 0, and then you keep the 20 minus pi r, right?
Mhm.
And then on the second part, you can keep the first function 2 pi and then differentiate the second part, which becomes negative pi, right?
Okay.
So 0 times this quantity is just 0.
Right.
And then 2 pi times negative pi is negative 2 pi squared. I think you can now see it. I think it should be clear because I have used the product rule.
Yeah, I didn't
It's
see that before.
it's a direct result of the product rule. Now, I just jumped the gun because I could see that the first part would become a 0. So I just went to the second part straight away. And then I kept the 2 pi, and then I differentiated the 20 minus pi r, got minus pi, and that was it. It was some sort of a shortcut.
Sure, makes sense.
Yeah.
Thanks.
Any more questions?
On this one, I think I'm good.
Okay. Perfect. We go back to the book.
I had one quick question for number 9.
Okay.
So I got the right answer, but the way that I did it and the way that I saw other people do it is by using a Pythagorean theorem to find the distance between the two.
Mhm.
But I wasn't sure if that would work if they were right up and down from each other. Like if it was a straight line just going up.
So how did you do number 9?
Let me go back to where I did it. Okay, so I set the distance between the point on root x on the curve as just xy, and then I have the point 1.5 comma 0. So the distance between the two is just using Pythagorean theorem. So, you know, x minus 1.5 squared plus y minus 0 squared, then the whole thing is square rooted. And then I found the derivative of that and set it equal to 0. And then solved for x.
Can you annotate?
I can try, yeah. I don't have a mouse today, but
Just try.
do you want me to draw the whole thing?
Don't draw, like you don't need to draw, but you can just write.
I can, okay, I'll try it.
I will assume I have the picture in my mind somewhere.
Okay, okay. Well, it would be easier for me to draw it actually, so let me just
Okay.
quickly do that. So we have these two. And then the line square root of x goes something like this. And then the other point that we have is like here, right?
Yep.
So if we assume that the point that we're trying to find along this line is like somewhere here, then we can set this distance with Pythagorean theorem is the square root of this squared plus this squared. Yeah.
Yep.
But the question that I had was, what if, oh, let me change colors. What if this line here wasn't always on an angle? What if it was, oh no. What if it was straight up and down?
If it
Like
was
this.
straight, then you would have to, subtracting the y's would be enough. Doing a y2 minus a
Okay.
y1 would be enough.
Okay. Sure.
Yeah. Okay, so 1.5, 0. The curve y equals square root of x. Just 1 sec. I don't know whether I'm overthinking it. So that is 1.5. This is the curve. And would you have to find this point, P?
Yeah.
Okay. And how would you find that?
I set the distance equal to the square root of those of y2 minus y1 squared plus sorry, x2 minus x1 squared plus y2 minus y1 squared.
To find the point?
To find the, what did I do? Sorry. To find the distance, and then instead of using y, I could plug in square root of x because we already have that equation. And then once we have the equation for the distance, then I can find the derivative of that to get the minimum point of distance, and the x value at that point, I can then plug that back into the square root and get the y value.
Yeah.
And then that's the coordinates.
Yeah, that's right.
Okay.
All right. Any more from this page?
From this page, I don't think so. Let me go see what the next one is. It's the next exercise, 4S, if you think it's on the next page. Yeah, here.
Okay.
The question that I had was on number 3. I think it might be because the problem is worded a little bit weirdly, but if you can figure it out.
So the production costs of XUSB flash drives made by a company can be modeled by that function. CX equals 500 plus 3x. The projected selling price is modeled by the function 7 minus 0.002s x. The projected revenues is that. So what do we need to find? The domain of the price function. So the domain, what do you think about the domain of the price function?
I thought by the price function they meant the projected selling price. But then I tried finding the domain for that, and it didn't work up. It didn't match up with the answer, so I'm not sure.
But I think this is the price function, is it not?
Yeah, it seems like it. I think
Yeah.
I must have done something wrong then.
Yeah, that is the price function. And what is the domain of that? Simple. 7 minus 0.002x.
Wouldn't it be all real numbers?
Can't be. Because you know, when you're talking of all real numbers, -1 is a real number, right?
Yeah.
But remember, x is the number of flash drives. Can it be negative?
Oh, no. Okay.
No, it can't. So you must work with positive numbers, starting from
Right.
0.
From 0. Okay.
Yeah. Yeah. So I think we could say the domain is 0 to infinity, maybe. But then again, can you have 0.2 as the number of flash drives?
No.
But let's just say 0 to infinity, because the numbers 1, 2, the natural numbers will be in there somewhere.
Mm-hmm.
Yeah. So I'd say 0 to infinity, simply because the number of USB drives cannot be negative.
Right.
Yeah.
According to the book, it's 0 to 3,500, but I'm not sure how they got there.
Oh, 0 to 3,500. Oh, look at the other argument. Can the price be negative?
Oh, no.
So the 7 minus 0.002x also has to be positive,
Right.
meaning that the 0.002x has to be less than 7.
Mm-hmm.
And so x has to be less than 7 divided by 0.002. Can you do 7 divided by that?
Yeah, it is 3,500.
Yeah, 7 divided by 0.002. It's going to be 3,500. So that's the other argument. So the number of USB drives cannot be negative. Also, the price cannot be negative. That's the argument. So it's going to be greater than 0. The x is greater than 0, but less than 3,500.
Okay.
Yeah. B, find the break-even points of the production. What is a break-even point?
Or the cost is the same as the price? Maybe.
Mm-hmm.
Or where the revenue is 0.
So if you take the revenues minus the cost, when these two are equal, then that is when we have a break-even point, you know? in business, a break-even point is when you return your money, right?
Oh, I see.
So if you invested CX and then you return RX, if the two are equal, then you are at the break-even point.
Okay.
So to get the break-even point, you just take the function CX. So 500 plus 3x equals 7x minus 0.002x squared. So this will be a polynomial. Let's write it in descending order. That's minus 4x plus 500 equals 0. Can you solve it?
Yeah. Just 1 second. Okay, there's one intersection at 133 or 134. And the other one at 1866.
So what did you get?
Okay, I got two x values. One is 134
Mhm.
and the other one is 1866.
Like that?
Roughly, yeah.
Break-even points. Oh, so they're allowing us to find two of them. Okay. Let me see what I get. Yeah, I'm getting the same thing. 134 and 1866. And both of them are within range, right?
Right.
Yeah. Why do you think we have two break-even points?
Why?
Because I'm trying to think about this problem in real life. Why would you have
Right.
two break-even points in business? Whenever I do business, I only have one. If I'm selling chicken, I don't have to sell two amounts for me to break even.
Right.
But anyway, you can think about that. So C, state the flash drive production levels in the form A less than X less than B that must be met in order for the company to make profit. So the equation for profit is going to be, we always calculate profit when we take our revenue and subtract the cost, right? So it's actually going to be, let me rewind this. It's going to be the same equation. Remember for B, we equated Rx to CX, right?
Mhm.
So for C, the revenue has to be greater than the cost, right? So Rx minus CX has to be greater than 0, right?
Right.
And we already solved such an equation before. So for us to get revenue or for us to make profit, we need the number of our flash drives to be in between 1866 and 134.
Okay.
Yeah, because we are just going to repeat the same process, but now instead of the equal sign, we are going to have the greater than sign.
Right.
Yeah.
That makes sense.
And what is the maximum profit that the company can make from sales of flash drives? Can you try that?
I think there's two ways we can do it. One that I'll do is with the derivative.
Mhm.
So we can take the derivative of that function that we just made.
Okay.
So that would be 2 multiplied by 0.002, which is 0.004 x minus 4.
Then we equate to 0.
4 minus 4, yeah.
So x becomes 4 divided by 0.004.
Which I think is 1,000.
Mhm.
Yeah.
So that's one way. What's the other way? You want to talk about vertex form of a parabola?
We could use the negative b over 2a equation
Mhm.
to find the x value.
So that
So that
becomes
would be
4,
4 over
0.04.
0. Yeah.
Again, it
That's
gives us
the x
1,000.
value. And then we
Perfect.
plug that into the function to
Mhm.
get the y value.
Yeah. Okay.
Yeah.
Awesome.
All right.
Good.
Thank you very much.
You're most welcome. I hope tomorrow's test will be as easy as today's lesson.
That would be very nice.
Yeah. Okay. Any more questions?
No, I think I'm good.
Okay. So I wish you all the best in, actually not tomorrow, Wednesday.
Wednesday, yeah.
Yeah.
Well, thank you very much. This has
Okay.
definitely been very helpful.
You're welcome.
I'll see you next week then.
See you next week.
Awesome.
Bye.
Bye.